Hello, my name is Trevor. I'm a data scientist, and we're going to be talking about defeating space invaders using reinforcement learning. The big question is, why would you use reinforcement learning in video games? The model itself doesn't know what's real and what's a game, so this is a perfect opportunity to train it in a virtual environment where you're not going to cause damage to, for example, if you're trying to stack boxes in a warehouse, you wouldn't have to potentially damage boxes or the warehouse itself while you're trying to train the model. So the idea is to start with a simple two-dimensional game such as Space Invaders, where you can transition to a 3D or virtual reality space and then onto a real-life environment. So getting started, we need to define a couple things. The agent in this case is going to be the human ship at the bottom, which the player would normally control. The action space can be divided into movement and shooting. For movement, you can be stationary, moving left, or moving right. And for shooting, it can be considered a boolean, which is either true or false. And the environment is going to be basically everything that the agent is interacting with. In this case, it's going to be the alien spacecraft, the lasers, as well as the barriers. And the important thing to note is the environment is constantly changing in this game. The aliens are shooting randomly, the player is shooting, the barriers getting destroyed, and the aliens are shifting sideways and moving down. So the process is basically we wanted to pass the environment information to the agent. Was able to do this by using the coordinates of the sprites. I transferred that to a matrix which I could pass to the agent. The agent will then choose an action, and based on that action the environment is going to change. We can use that change to define a reward, and the agent will use that reward to learn what the best behaviors are to get the best rewards. This doesn't necessarily work out perfectly all the time, so we would have to adjust the rewards to kind of influence the behavior. So I have a couple of videos here. On the left we have an agent that's just using random choice to pick its actions, and on the right we have our DQN agent, which is kind of found an optimal strategy. So I'll play these for you. And we can see the random choice is just kind of moving back and forth, shooting at random. It's definitely not very consistent. On the right, with our agent, the agent has found a very good strategy of hanging out on the right side where it can kind of avoid fire and return fire from safety, and it's been able to do that quite effectively. The average score over 25 games for the random one was about 3,500 points. And with the agent, over the 25 games, got an average score of almost 8,000. So it did quite a bit better than the random choice model. The next steps, though, I would definitely like to increase the memory of the model, just because our model was not very defensive. And so I'd like to kind of increase the range of the memory to hopefully make it a little bit more defensive. Would also like to use different ways of passing the environment to the agent, using image processing, which would make it a little bit better translation to games that aren't necessarily built in Python. Alright, that's the presentation. Thank you for listening in.